Welcome back, ladies and gentlemen. In this video, we are discussing part 2 of our parallelogram characteristics. Part 1, let's recap for a sec. We discussed that opposite sides are parallel for a parallelogram. We discussed that opposite sides are congruent. Opposite angles are congruent. And in this video, the goal is going to be able to define and utilize the last two characteristics of parallelograms. And in order to do so, I want to bring up a topic that we discussed back in chapter 3, known as the consecutive interior angles theorem. If you remember correctly, the consecutive interior angles theorem said if two parallel lines are cut by a transversal, then the consecutive interior angles, in this example up here in the top right corner, x and y, are supplementary to one another. Well, think about this, guys. We have a parallelogram. Remember, opposite sides are parallel. If this is the case, let's think about QR and PS. Do we notice the connection? QR and PS are the two lines that are parallel, and QP would be a transversal cutting those two parallel lines, thus making X and Y. Maybe if I connect this on out, we'll be able to see it a little bit better. Right, now making X and Y not being congruent, but being supplementary. So I can make the statement that X and Y equal 180 degrees. So let's go back to our list, and we can say that number 4 is that consecutive angles are supplementary. And we have one more, all right? We'll have one more that we can use here in application. What is it? Well, if you remember correctly, we were discussing polygons in general, convex polygons. We discussed a lot about their diagonals because their diagonals end up creating these triangles that help us determine the interior angle sum. So the diagonals come into play a little bit for our parallelograms as well. The diagonals of parallelograms bisect one another. So they split each other in half. We're not saying diagonals are congruent. Be careful. That is not true for every parallelogram. We'll talk about that later. That is not true for every parallelogram. But the diagonals are bisected by each other, making it two congruent halves. And so let's go on over back to our list and finish it off and say that the diagonals bisect each other. So there are our 5 characteristics of parallelograms. Now let's do some application. What do we know? In the following diagram, we have a parallelogram, and it wants us to find the values of A and B. Well, since these are parallelograms, my 5th characteristic said the diagonals bisect each other, meaning that these two are congruent and these two segments are also congruent, respectively. So I know that 2 will equal A minus 7 because of their congruency, meaning that A is equal to 9. And I know that 10 will equal 2B, 10, be 2B minus 6 because of their congruency. So I have 16 equaling 2B, and B ends up equaling 8 after dividing through. Let's try one more. Again, our 5th characteristic says that parallelograms have diagonals that bisect one another. Let's go ahead and solve for B and W in this case. I know that since F to this point of intersection is congruent to the point of intersection to H, I can set 4W minus 7 equal to 2W plus 3. Subtracting 2W on both sides gives me 2W minus 7 equals 3. Adding 7 to both sides give me that 2W equals 10. And then after dividing, W will give me 5. Very similarly, I will go ahead and set 3B plus 1 equal to 2B plus 5 because of their congruency. And subtract the 2B on both sides, you get 3 minus 2, which is 1B, and subtract the 1 on both sides, you get B equals 4. And so let's recap one more time. Our 5 characteristics are that opposite sides are parallel, Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. And last but certainly not least, diagonals bisect each other.